Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is application of derivatives. In this video, we'll be focusing on NCERT solutions for exercise 2. In the first problem, we need to show that the function f of x given by this is strictly increasing in R. What is condition for strictly increasing is f dash x should be greater than 0. Then the function is strictly increasing. So let us find that f dash x is equal to 3. Derivative of 3x is 3. 17 it is 0. So f dash x is 3. F dash x is greater than 0. The function is strictly increasing. The function is strictly increasing. Please remember this condition for increasing and f dash x less than 0 for decreasing. We need to show that the function given by f of x equal to sin x is strictly increasing in the region 0 to pi by 2. So we'll remember that condition f dash x must be greater than 0 for increasing. So f dash x here is sin x derivative is cos x. Now what happens to cos x between 0 and pi by 2? It is always greater than f dash x is always greater than 0 for x between 0 to pi by 2. We know that f dash x this cos x is positive for angle between 0 to pi by 2. So f of x is increasing, strictly increasing in 0 to pi by 2. Now we need to show that the same function is decreasing between pi by 2 to pi. So what is the condition of strictly decreasing? F dash x must be less than 0. So we'll find f dash x, which is cos x, we know. Now pi by 2 to pi refers to second quadrant. This is first, this is second quadrant. We are talking of this region, pi by 2 to pi. But what is happening in second quadrant? Only sine is positive and cos is negative. So f dash x is less than 0 for x belonging to pi by 2 to pi. In this region cos x is negative. So what will happen? F of x is strictly decreasing function. Now in the interval 0 to pi we need to show that the function is neither increasing nor decreasing. So again we'll check f dash x equal to cos x. And what happens to cos x between 0 to pi? 0 to pi can be written like this. Can be written 0 to pi by 2 union pi by 2 to. What happened to 0 to pi by 2? We have seen increasing, and pi by 2 to pi cos x is decreasing function. So the function is f of x is neither increasing nor decreasing in the region 0 to pi. Find the intervals in which the function is strictly increasing and strictly decreasing. Let us, for increasing and decreasing function, we need to find f dash x equal to 4x minus 3 for this. Now we equate it to 0. So x equal to 3 by 4 is the critical point. So what happens when 3 by 4? When x less than 3 by 4. What happens to f dash x? When this is less than 3 by 4, f dash x is less than 0, correct? So f of x is decreasing. Now what happens when x greater than 3 by 4? F dash x is greater than 0 always. So f of x is increasing. So this is the region. You can say minus infinity to 3 by 4. The function is decreasing, and 3 by 4 to infinity, the function is increasing. Find the interval in which this function is strictly increasing or decreasing. So we will again take derivative f dash x, 6x square minus 6x minus 36. So we can take 6 common, x square minus x minus 6. Now we have to factorize such that the sum is minus 1 and product is minus 6. So we can write 3x, yes, minus 3x plus 2x minus 6. So we can factorize it easily. Can write it 6 x plus 2 x minus 3. So we equate it to 0 to get the critical point. So critical point is x equal to minus 2 and x equal to 3. So we'll check what happens when, we'll check here, when x less than minus 2. What happens from this case? When x is less than, we'll check the sign of this 6x plus 2 into x minus. We have to check sign of this function always. So when x is less than minus 2, this term will be negative. This also will be negative. The result will be positive. F dash x is positive. F dash x will be greater than 0. This is f dash x. Will be positive. So f of x increasing. What happens when x is between minus 2 and 3? So when x is say minus 1 here. So when minus in this, it will become more negative and this will be positive. So result will be, product will be negative. So f dash x less than 0, f of x decreasing in this region. This is one. Now third condition is x greater than 3. When x greater than 3, this will be positive and this also will be positive. Product will be positive. So f dash x is greater than 0. F of x is increasing. So we have found the region for increasing and decreasing function. So in this function, we need to show that y equal to log 1 plus x minus 2x by 2 plus x for x greater than minus 1 is an increasing function. So what is the condition for increasing function? Y dash greater than 0. The first derivative should be greater than 0 for increasing. So we will find y dash equal to 1 by 1 plus x minus 2 plus x the whole square. Denominator into derivative of numerator is 2. 2 into 2 plus x minus numerator into derivative of denominator, which is 1. So this will be 4 plus 4 by 1 by 1 plus x minus 4 by 2 plus x. We can take LCM and get y dash as x by 2 plus x the whole square into 1 by 1 plus x. We got this through taking LCM and solving. Now what happens to this function? This is always positive because this is a square term is there. This is always positive. What about this term? Since x is greater than minus 1, this term also will be positive always. So both terms are positive. So y dash is greater than 0. Y is an increasing function. So in this problem, we need to show that this function is increasing. The condition is y dash should be greater than 0. So let us expand this. Y equal to x square minus 2x the whole square So this will be x power 4 plus 4x square minus 4x cube. So y dash will be equal to 4x cube. Derivative of this is minus 8x square plus derivative of this is 12x square plus 8x. So we can take 4x common, x square this is minus 3x plus 2. So this can be written as 4x, x minus 1, x minus 2. We equate it to 0. So x will be 0, 1 and 2. So we will find different cases and check the derivative condition. What is derivative here? We got here. Derivative is 4x, x minus 1, x minus 2. So whenever y dash is greater than 0, that will be increasing. So we have to find that. So the three regions are, in fact there will be 4 regions. So first is x less than 0. What happens when x less than 0? This will be negative, this will be negative, this will be negative. So product of 3 negative will be negative. So y dash will be less than 0, y is decreasing. What happens when x is between 0 and 1? Between 0 and, so this is positive, this will be negative, this will be negative, the product will be positive. So y dash greater than 0, y is increasing. What is the second region? Second region is x is between 2 and 1. So between 2 and 1, this will be negative, this will be positive, this will be positive. So the product is negative. So y dash less than 0, y is decreasing. What is the fourth region? Fourth region is x greater than 2. What happens when, so this will be positive, this will be positive, this will be positive. Y dash is greater than 0, y is increasing. So we see two places. One is this and one is this where y is increasing. So what is that region? Y is increasing in x between 0 and 1 and x greater than 2. So this is the solution. So this is the region where y is increasing. Prove that the log function is strictly increasing between 0 to infinity. So how do we do it? Let y equal to log x, dy by dx equal to 1 over x. But between 0 and infinity, dy by dx or 1 by x, which is 1 by x, is always greater than 0. So dy by dx is positive. Hence y is strictly increasing in 0 to infinity. In this problem, we need to show that the function given by is neither increasing nor decreasing in this regime. So let us find f dash x, 2x minus 2. So this will equate it to 0. 2x minus 1, sorry. So x will be equal to half. So we get x equal to half. So we need to check the condition. What happens when x is between half and 1? Half and 1. We can check the condition x is between half and 1. What happens? Here let us try to find it out. So when x is between half and 1, this quantity f dash x will be positive. So f of x is increasing. You can put any value, say 3 by 4 here. So we can see that this function will always be positive. So this is increasing. What happens between x between say half and -1. -1. Why we have taken 1 and -1? Because this is the regime where we need to show. So when x is between half and -1, we see that f dash x is less than 0. So the f of x is decreasing. So what we observe that within -1 and 1, the function is neither increasing nor decreasing. Neither increasing nor decreasing. That's what we wanted to show. Find the value of the function when this takes strictly increasing on the region 1 and 2, not including 1 and 2. So how do you find f dash x equal to 2x plus a? So when x is equal to 1, let us put when x equal to 1. So this will become 2 plus a. 2 plus a. This should be greater than 0. F dash x should be greater than 0 for increasing. So here put this a greater than -2. Similarly, when x equal to 2, this will become 4 plus a greater than 0. We are substituting x equal to 2 in this. So 4 plus a or a greater than -4. So what is the condition when both are satisfied? Both are satisfied when a greater than -2. So the minimum value of a is -2. Let I be interval disjoint from this. What do you mean by disjoint from this? It means x is not in this. So x is greater than 1 and x is less than -1. That is the condition we need to check and show that this function is strictly increasing in this region. So let us find f dash x equal to 1 minus 1 by x square. So now what happens when x is greater than 1? X is greater than 1 means 1 over when x greater than 1 over x square is always between 0 and 1. Correct? Whenever x is greater than 1 by x square is always between 0 and 1. So f dash x will become always positive. If this is between 0 and 1 minus that small number will always be positive. That's what I have written. So f of x is increasing here. What happens when x less than -1? So again we see when this is less than -1, this quantity will again 1 over x square is always between 0 and 1. So f dash x is always greater than 0 and f of x is increasing. So f of x is an increasing function in the region I. For the disjointed region or this particular region, it is increasing function. So in this function we need to show that it is strictly increasing in this and strictly decreasing in this. So we will find f dash x equal to log sin x, derivative is 1 over sin x, into derivative sin x is cos x. So this is equal to cos x by sin x. So what happens between 0 when x is belonging to 0 to pi by 2? What happens? It is in the first quadrant and both cos x and sin x are positive. So f dash x greater than 0. So f dash x greater than 0. So f of x is increasing. What happens between pi by 2 to pi? This is in the second quadrant. In the second quadrant, sin x is positive but cos x is negative. So f dash x is less than 0. So f of x is decreasing. So it is required to be shown. in this question this is MCQ question, so we need to show that x square e power minus x is increasing in which region. Okay, we'll find it out. Y dash is equal to x square into derivative of e power minus x, e power minus x into derivative of minus x minus 1 plus e power minus x into 2x. So we can take e power minus x common. So this will be 2x minus x square. X also can be taken common. We will get 2 minus x. When we equate it to 0, x will be 0 and 2. X will be 0 and 2. So we will find the different region. So when x less than 0, when x less than 0, what is the derivative sign? This will be negative. This will become positive and the result will be negative. So when x less than 0, y dash will be less than 0, y is decreasing. What happens between when x is between 2 and 0? When x is between 2 and 0, we will see the derivative condition here. So this is positive. This also will be positive. Result will be positive. So y dash greater than 0, y is increasing. When x greater than 2 condition. Let us see what happens when x is greater than 2. This will become negative. This is positive, so result will be negative. Y dash will be less than 0, y is decreasing. So we see between 0 and 2, the function is increasing. So correct option is D. Friends, with this we conclude this video. Please like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.